So good morning all. Today we are going to see a detailed activity on convolution neural network. As you all know what is convolution neural network. So this convolution neural network is a deep learning model. It is an advanced deep learning model of your artificial neural network. So here you have convolution layer, pooling layer and fully connected layer. These layers will convert your input image which is given in matrix form. It will convert it into the input image, and then finally you will get a feature map without manual feature engineering. Let's see a role play activity on this convolution neural network.
Myself Hamish, I am going to explain why we use the CNN. So CNN is nothing but convolutional neural network. So instead in deep learning we have a dense layer. So in this dense layer they have a non-linear capability to predictions of the objects. But we want to use the dense layer in the CNN, it could not predict that because the images are in the matrix format. We want to extract the matrix edges and features in the images. Like it want to extract the feature of a neighboring pixels like edges and shapes of your images. So from this we can use the images, it is a cat or it is the dog. So that's why we use the CNN.
Myself John. Now I am going to say about limitations of traditional methods. Traditional image processing and machine learning methods have several limitations. They require manual feature extraction, which is time consuming, and heavily rely on human expertise. These methods are also failed to handle large image datasets and variations in scale, notations, and lighting. As a result, their efficiency and accuracy is limited when dealing with complex features.
On the traditional method, they have a lot of the limitations. These limitations are overcome by the CNN by this convolution operation. So on the convolution operation, it is used the shared the weights and the local connections. So which is reduce the complexity of conceptual complexity, and then it is load the lot of the larger data sets, and then also is robust to variance by size and orientations. And then the CNN makes it more scalable and uses a lot of the image processing in convolutional neural network.
Myself June Anderson, and I am going to tell about the architecture of the CNN. In architecture we see many layers. The CNN consists of many layers. First we see input layer. In input layer we implement the image content. That image has the image content pixels value. So when we get the image, we move on to the convolution layer. In convolution layer, we used to extract the features by the using of kernel, means filter. In the by measuring and filtering, extracting the feature, we can produce the feature map. After finishing the convolution layer, we move on to the active function, mean redo. So in this, we introduce a non-linearity to this model because if we get a negative values in the pixel, that model cannot be predicted, so we convert the negative value to 0. This is done by the redo method. After we converting non-linearity to the model, then we move on to the, so after finishing the activation function, we move on to the pooling layer. In the pooling layer, we used to reduce the size of the pixel value by maximizing and average pooling. Why we take this pooling layer? Because this prevents the overfitting method in the model. So after finishing the pooling method, we go on to the flatted method. All the dimensional matrix layers are converted into 1D layer, 1D dimensional matrix. This helps to go on to the another layer fully connected. In fully connected, we all the neurons are connected in the same. We use in softmax. Softmax, why we use it? Because multiple classification method, we use a soft method to classify them. After the fully connected is move on to the output layer. Output we can extract and see what the output is.
Hi, I am Arvind. I am going to talk about challenges of CNN. CNN has several limitations. They require manual extraction, which is heavily depends on human and takes time consuming. These methods also fail to handle large image data sets. As a result, the accuracy and efficiency of CNN limits when they are dealing with high complex images. Thank you.
Now let's see the convolution neural network. network with an example input image.
So for example, we have an image of 5. So the image is in the matrix format. So it considers a 28 into 28 pixel. Okay. So for example, I am giving this 5 images to this first convolutional layer. So the convolutional layer may blur the image. Like let's compare this 5 and 5. So in this images, input images, and in the convolution. So here the convolution have a blurred of 5. So but the feature, maximum feature is extracted here. So and then next we have a ReLU layer. So in this ReLU layer we have the important information of the. So next the ReLU layer. So in this ReLU layer we have the convolution images next turn into the ReLU layer. So the ReLU layer holds a non-linearity. So it provides a maximum of positive values. So next the ReLU layer values are converted into max pooling. So here the 5 is zoom into the max pooling layer. So and then this process continues until the stack of convolution and ReLU and max pooling. So next convolution layer. So here the convolution layer 2 and ReLU layer 2 and max pooling. So this process continues. Okay. So and then next we have a flattened layer. So in this flattened layer, here we compare the max pooling layer with the flattened layer is same, but the dimension is converted into 1D vector. So now the max pooling is converted to the flattened layer. The flattened layer is nothing but it reduces the dimension to 1D vector. Here the max pooling and flattened pixels are same, but the dimension is converted into 1D vector. So next we have this flattened layer is here. So the flattened layer is now feed forward into the deep neural network. The deep neural network is nothing but it consists of nodes of neurons. So where the neurons are connected in the fully connected neural network. So here the input layer of a neuron. So why we use the 4 input means we have the matrix of 4, then it converted into the flatten of 4 pixels, then the same 4 pixel is feed forward into the input layer of a neural network. So now next the input layer is converted into the input layer is feed forward to the hidden layers. So the hidden layer consists of a weights and bias. So it holds the information of a pattern. So next the hidden layers consists of a output layer. Next the hidden layer after output layer. So the output layer is it have a 0 to 9. So why we have a 0 to 9 means we predict the number of 5. Okay. So the digits are have a 0 to 9. So we have prediction of 0 to 9. So in this case the 5 is predicted here. So looks like this 5 is predicted in the output.
So I hope you are clear with convolution neural network. So convolution neural network has convolution layer, pooling layer, and then you have the flattening and the fully connected